When it comes to generative AI, that safety policy you wrote yesterday, it's probably already obsolete. The real question isn't just if your system is safe right now, but how do you know it's staying safe, second by second, as these models drift and attackers get smarter? So today, we're going to talk about moving beyond those static rules to build a safety system that's actually alive and adaptive. All right, so here's the game plan. First, we'll talk about why the old security playbook just doesn't work anymore. Then, we'll get into the big trap, security theater. From there, we'll pivot to the solution, which is all about an observability mindset. We'll break down the 5 signals you absolutely have to watch, look at a real-world disaster, and wrap up by reframing the most important question you should be asking about AI safety. So first up, why can't we just take our old application security tools, point them at a Gen AI stack, and, call it a day? Well, it's because the thing we're trying to protect has fundamentally changed. We're not guarding deterministic code anymore. We're trying to secure a probabilistic system that's constantly in flux. And this slide really just lays it all out, doesn't it? On the left, you have traditional security. It was kind of like a fortress with known weaknesses. We could build static rules and look for known attack signatures. But on the right, that's the world of Gen AI. It's this dynamic, unpredictable system. We're defending against attacks literally written in English, where the model's behavior isn't just a little random, it can completely change on you with the next update. And this new reality, this new frontier, leads us right into a really dangerous trap. And that trap is called security theater. It's this belief that you can just plug in a simple content moderation API and suddenly, poof, you're secure. But in reality, that often just creates a false sense of security, which is actually way more dangerous. I mean, this quote just nails it, right? If you can't continuously measure how well your defenses are actually working, you don't really have security. You're just putting on a show. You're hoping your policies work. It's exactly like installing a firewall and then never, ever looking at the logs to see what's going on. So when you're flying blind without data, you're stuck on this awful seesaw of failure. On one side, you overblock. You're so restrictive that you frustrate your users and they just leave. On the other side, you underblock, and you're leaving the door wide open for some massive legal or security disaster. Real safety isn't about picking which way you'd rather fail. It's about using data to find that perfect, dynamic balance point. So how do we get off this seesaw? How do we escape the theater? Well, the answer isn't a better static rule. It's a complete paradigm shift, one we've borrowed from the world of large-scale distributed systems. It's all about adopting an observability mindset. We have to stop treating safety like a feature we build and start treating it like a dynamic, living system that we need to constantly understand. And that brings us to this key idea: continuous policy observability. Now, this isn't some product you can buy. It's a discipline. It's about instrumenting every single layer of your Gen AI system, from the user's prompt to the model's output to any tool it might call, so that it's constantly telling you how your policies are actually performing, not just how you hoped they would perform. Okay, so what does that actually look like in practice? It means your operations dashboard needs to answer these questions at a glance. Look, if you can't pull up a dashboard and answer every single one of these questions, like right now with real-time data, you've got massive blind spots. And in a Gen AI system, those blind spots are exactly where failures happen. All right, let's get into the nitty-gritty. If you want to build this observability layer, you have to start with these 5 signals. Think of these as the absolute non-negotiable vital signs you have to be monitoring all the time. First up, we've got policy trigger rates. Seriously, think of this as the EKG, the heartbeat of your safety system. You have to know what your normal baseline is for things like safety refusals. A sudden spike or drop in that rate is your canary in the coal mine. It's the earliest warning sign that something fundamental has changed in your system, long before you find a specific problem. Second, jailbreak attempts. And let me be clear, your static block lists, they're totally useless here. Attackers are creative, they're constantly evolving. Your system needs to detect the semantic patterns of an attack, things like trying to confuse the model about its role. This is about understanding the intent of the attack, not just matching keywords. Third, PII detection. And this is so much more than just flagging a phone number. You absolutely have to know the source. Did the user provide the sensitive data, or did the model leak it from its training data? That distinction is everything. One is a user input issue, the other is a potential 5-alarm data breach. Number 4 is prompt injection. Now, it's really important to understand this is not the same as a jailbreak. With prompt injection, the goal is to trick the AI into becoming what we call a confused deputy.
An attacker sneaks instructions into the context that hijack the original system prompt and make the model do something it was never supposed to. You have to be watching for this kind of logical manipulation.
And finally, number 5, tool abuse. The second you let your AI use external tools or call APIs, bam, your attack surface just exploded. An attacker could use plain English to try and trick the AI into making unauthorized API calls. This is a huge, huge risk for privilege escalation, and you have to be watching it like a hawk. Okay, so all this theory is great, but let's see what happens when it's missing in the real world. This is a look at a real production failure, and it shows why all of this is an absolute operational necessity, not just some nice-to-have feature. So get this. Here's the situation. An AI assistant suddenly starts giving out financial advice it was explicitly programmed not to. The team's first guess? A new jailbreak. Totally logical, right? So they start wasting all this time hunting for some clever user attack. But the data? Oh, the data told a completely different story. The refusal rate had plummeted by 60%, but there was no spike in jailbreak attempts. The real cause? A recent model upgrade. The new model just interpreted the old safety policy in a different way. The model didn't break the policy, the upgrade broke the policy itself. And that story is exactly why the alerts you set up have to be about these big systemic shifts. You don't alert on every single bad prompt, no. You alert when your refusal rate baseline drifts significantly. You alert when a new cluster of jailbreak patterns shows up. And as you can see here, you should have a specific alert just for policy drift that triggers after any model or prompt change. It's a total mindset shift. You're becoming a doctor for your AI system, monitoring its overall health, not just acting like a traffic cop. So when you put all of this together, the new threats, the need for deep observability, the fact that your own updates can break things, it all boils down to one huge mental shift you have to make to keep these systems safe. And here it is, the most important thing to take away from all this. AI safety is not a rule set you write once and forget about. It's a living, breathing system. Your model drifts, your prompts evolve, and your adversaries adapt. So your safety measures can't be a static wall. They have to be more like an immune system, constantly sensing what's happening and responding to it. And that finally brings us to the ultimate question, the one that should be at the top of your mind. We spend so much time obsessing over whether the AI gave the right answer, but safety observability, it forces us to take a step back and ask something much, much more fundamental first. Should the AI have even answered at all? Because if you can't answer that question with data for every single request, you're not managing risk. You're just flying blind.